So whenever we take a derivative, we have basically two options. We can apply the definition of the derivative, the limit as h goes to 0 of f of blah, blah, blah. Or we can use some of the shortcut rules we have and or some algebra. So I'm going to use some algebra here, and then I'm going to use another derivative rule instead of using the limit of the difference quotient, the definition. And so I'm going to remember that tangent is sine over cosine. So then I want to take the derivative with respect to theta of the sine of theta divided by the cosine of theta. So that's another way to define the tangent. And then I know the quotient rule. So I can apply the quotient rule, and I know the derivative of the sine and the derivative of the cosine. So the quotient rule says take the derivative of the numerator first. Derivative of sine is cosine. And multiply by the bottom function, which happens to be another cosine. Then the quotient rule says subtract the derivative of the denominator. The derivative of the denominator, the derivative of cosine is negative sine. So I'm going to get a negative sign here, which is kind of nice. Negative times a negative is a positive, times the numerator, which is the sine, theta. And all of that is divided by the denominator squared. So cosine squared theta. That's what the quotient rule tells us right away. This numerator is actually quite beautiful. Since I am subtracting a negative, right, that becomes a positive. And so my numerator becomes cosine squared of theta plus sine squared of theta, all divided by now cosine squared still. And one of two things might jump into your head here. You're thinking maybe, oh, yeah, I can wipe out those cosine squares. No, actually, you can't easily do that. What should be a more prominent thought in your head based on your previous work in trigonometry is that this is the Pythagorean identity for trigonometry. Cosine squared plus sine squared is 1. And that is a better way to handle this. So now I have that the derivative of the tangent is equal to 1 over the cosine squared, which I could also write as 1 over cosine squared, square on the outside, because 1 squared is 1. And hopefully you remember that 1 over the cosine is the secant. And so I could also write this as the secant squared of theta. All right, let's try another one. So we have sine, cosine, and tangent so far. We need to figure out secant, cosecant, and cotangent.